Welcome back, algebra students. Today we're continuing on with our rate of change and slope. We got a couple fun, not a couple fun problems to do today. First, I want to talk to you rate of change. The rate of change tells, on average, how a quantity is changing over time. So remember, our slope m was our change in y. Change in y over change in x. So that was slope. So the rate of change is how does y change in relation to x changing? So some rates that we use often is miles per hour. And if you notice, the fraction bar is our what we call per. That's division. A rate is a division. It's the change in the miles over the change in the time. Miles per gallon we use a lot. We use different rates. And so what we're doing here is we're going to look at the rates. It's going to be the change in population over the change in time. All right, so population. The graph shows the population growth in China. Find the rates of change from 1950 to 1975, and then we're going to find it, and I'm going to do this in green. We'll do the rate of change from 2000 to 2025. So first thing I want to do is I want you guys to recognize that from 1950 to 1975, and I'm going to do this in red, we were drawing triangles, and the triangles represent the change in y over the change in x. So change in population. So 0.93 minus 0.55, that's our vertical. That's going to give us 0.38. So 0.38 over, so we got 0.38 here, over our run, how many years went by. So from 1950 to 1975 is 25 years. So what we have is 0.38 divided by 25, which equals 0.0152. And then that's the rate of change from 1950 to 1975. Now we're going to do from 2000 to 2025. So I'm going to draw my triangle again. And it doesn't have to look perfect, but so my run again is 25 years, so my horizontal is 25, but my going up and down, so I'm going to do 1.45 minus 1.27, which gives me 0.18. So 0.18. So my change in y up and down is 0.18 divided by my change in x, my horizontal, was 25 years. So 0.18 divided by 25 gives me 0.0075. So if you notice, from 1950 to 1975, the rate of change in the population was higher than the rate of change in 2000 to 2025. So part B, explain the meaning of the rate of change in each case. And so from 1950, and remember, this is in billions of people. Billions of people. So when you're looking at this and you're like 0.0152, oh, that's not a lot, but it's actually of a billion people. So it's actually, if we were to kind of go down to it, billion has 9 zeros, so we would move the decimal 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it actually would tell us that it's 15 million people per year more. So that's actually a big number, guys. I just wanted to show you that. So that's what we had. The growth was 0.0152 billion per year, but 0.0152 of a billion is 15.2 million per year. So that was the rate of change. That's a lot of people. Then we looked at the rate of change from 2000 to 2025. It was 0.0072, but remember that's of a billion people, so we had to add 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0, 0, 0, 0, 0. So that would be 7.2 million per year. So that's a lot of people. Notice, how are the different rates of change shown on the graph? Well, the greater the vertical change, right? There is a greater vertical change for the first rate from 1950 to 1975. However, the horizontal is the same. So there is a greater vertical change from 1950 to 1975 than 2000 to 2025. We notice that. Therefore, the section of the graph from 1950 to 1975 is steeper. And we know that because if we were to draw our line, we draw it a little differently. So it's a little bit steeper. So that's how you're going to do this problem. I'm going to go ahead and I'm going to work on it with you guys. Longevity. The graph shows the predicted life expectancy for men and women born in a given year. All right, so find the rates of change for women from 2000 to 2025. So first I'm going to do the women. Women are the ones with the boxes. If you see that, the boxes. So they're the top one. And so we're going to do our triangle, and it went up 4 over 25. So from 2000 to 2025, our slope equals, it went up 4 over 25, which equals 0.016, just 0.16, sorry, per year. So it's 0.16 per year. Each year it grew by that. So now let's look at the second one, all right, from 2025 to 2050. So we went up 3 this time over 25. So it was m equals 3 over 25, which is 0.12 per year. So life expectancy grew by 0.12 per year. By 0.12 each year it grew. So now let's look at the men. Same thing. So I went up 4 over. Actually, I'm gonna let you guys do the men's. So it went up 4 over 25, and it went up 3 over 25. So it's the same thing as the women's. So you're going to have to, you can go ahead and do that one. Explain the meaning of your results in exercises 1 and 2. What you're going to realize is that they have the same 4 over 25 and 3 over 25. They have the same rates of change, but they weren't consistent all the way through. So the life expectancy change of rate for 2025 to 2050 was a little bit lower. So you're going to have to put that in words. What pattern do you see an increase with each 25-year period? So what I said was that life expectancy increases each year, but not at a constant rate. So for C, what you're going to say is they both have the same increases over the same time spans. For D, you're going to put that they both increase, but not at a constant rate. So I'll actually write that in here. put it in red. So for D, it was life expectancy increases, but not at a constant rate. And I'll put in the answer for C as well. So both men and women increased their life expectancy the same rates. Because what you're going to find is for B, it's going to be the same as A. And then for E, make a prediction for the life expectancy for 2050 to 2075. Well, I'm going to let you guys do that on your own. Those answers can vary, so you guys can come up with that on your own. But if there's any questions, reach out. All right, guys, have a good one.